This question says the solubility of FeOH2 in water at 25 degrees Celsius is measured to be 5.2 times 10 to the minus 4 grams per liter. Use this information to calculate the KSP for iron 2 hydroxide. So this is kind of a combination of the previous two questions. In the first question, you'll get there's a look at how we would find this reaction, but it's FeOH2 as a solid is reacting to form Fe2 plus aqueous plus 2OH minus aqueous. And on the first video in the playlist, it goes through how you find out that this is Fe2 plus. So what we're going to look here for is essentially an ice table. So we have an initial, a change, and an equilibrium. And we're going to have a KSP expression, and the KSP expression equals the concentration of Fe2 plus times the concentration of OH minus squared. So this is basically what we're looking for. But in this case, we are not given concentrations of these things. Instead, we're given a solubility of this in grams per liter. Well, the initial amount of this is 0, and the initial amount of this is 0. For every 1 mole of this that breaks up, we'll get 1 mole of this and 2 moles of this. Said another way, if we know the molarity of this, moles per liter, we can figure out what the change will be for this and this. So how do we do that? Well, we have 5.2 times 10 to the minus 4 grams of FeOH2 per liter. Times, we want to get this into moles per liter. So we put 1 mole of FeOH2 on the top, and the molar mass, which is 89.86 grams of FeOH2 on the bottom. And when you do that math, we find that the molarity of FeOH2 is 5.7868, where that's the sig fig, times 10 to the minus 6 molar. So if this is the concentration of this when we dissolve it, it's going to be the same for this because they're 1 to 1. So we can plug this in. 5.78 plus 5.7868 times 10 to the minus 6. And for OH2, it's going to be double of this, because for every one of these that dissolves, we get 2 of these. So if we multiply that by 2, we have plus 1.1574 times 10 to the minus 5, and that is molar. So at the end of the day, this is 5.7868 times 10 to the minus 6, and this is 1.1574 times 10 to the minus 5. Well, we have our KSP expressions, and we have our equilibrium concentrations. So we just plug in KSP equals 5.7868 times 10 to the minus 6 times 1.1574 times 10 to the minus 5 squared. Because there's 2 OH's, we do have to square it. So we take this and we multiply it by this squared, and we round to 2 sig figs, because these are both 2 sig figs. And what we get is the KSP equals 7.8 times 10 to the minus 16. So again, this is a bit of a combination of the previous 2 questions on the playlist, and it may be helpful to review those as well.